doing?
Everybody signed in? Here we go. Statistical quality control. Is there anybody that signed up for 302 in the fall with the other professor? Is there anybody who signed up for the other professor? No one did?
Her classes are full.
Mine are full, but hers?
Yeah, I mean, like they're empty.
They're empty, but there's 12 people in there, so I thought maybe at least one person from here signed up for it. Because there's like 12 in there. Well, she will most likely start the semester off reviewing this, is my guess. And the confidence intervals, for sure confidence intervals. And I'll start the semester off reviewing confidence intervals, but we will not be reviewing this in 302 in my class, which I think a lot of you signed up for. So this may be the only time you see it in statistics. But operations management, does anybody have operations management right now?
Right now, yeah.
You are taking it right now?
Yeah.
Did you do quality control yet?
No. Oh, actually, yeah. It's like we're working on it right now.
You are? Okay, so that's another place you're gonna see quality control. Quality control is such a big part of manufacturing, huge. And we happen to be in southwest Detroit, which is a huge manufacturing area. Manufacturing is so big that this is a particularly good subject. Matter of fact, I don't have my cord. I was gonna get on the internet, go to Indeed, and just do a search for quality. You don't even have to put quality control, quality statistician, quality manager, just put the word quality, and you will see how many job opportunities. If anybody finds this interesting, if somebody says, I am a numbers person, and I like this, what you're about to learn today, this is a great way to get in entry-level job at a company. This is a great way to get your foot in the door is being a quality control staff person that does quality control. Because there's a whole bunch of people who hate numbers, who hate statistics to the point to where they think you are special. Wow, you're doing quality control, well, that must be special. And so what happens is quality control manager job's gonna open up. I can't think of a quicker path to get to $100,000 income, probably in like as little as 4 years from the date you graduate, is quality control. That's the kind of path it is. Maybe computer programming would be another path to get you there fast too, but quality control would be one. And it gets you into top management because quality control is a type of position that looks like you have some kind of special talent in some way. You're gonna add some to it?
Yeah. What field would that fall under?
It's part of quality control. Is any manufacturing company uses it. Almost all of them do. But in the old days, the big companies used quality control. The suppliers were not using it yet, and that's why I don't know if anybody, if you have, ask your parents. Ask your parents to say, look, when you were a kid and your parents came home with a car, how long did that car last? Back in the day, I'm going back into the 1970s, even the late 60s and 1970s, when I was a child, my parents came home with a car, it only took 4 to 5 years to be rusted out. Cars were just breaking down all the time. That was it, 4 to 5 years. It was unheard of to get 100,000 miles on a car. It was like a miracle if you got 100,000 miles. So the quality of how cars were made is a perfect example of where quality control took an industry and revolutionized it to where, I know all kinds of people that are getting 200,000 miles out of a car now. Am I the only one that knows that? Is there anyone else that knows people getting 200,000 miles? And how many years? You see cars that are way over 10 years old with no rust on them anymore, and we still put salt on the roads here in Michigan. And that's how much quality has changed because of quality control. That's what revolutionized the quality of products and a manufacturing process. So here's, I don't even know where to start this. Let me give you an example of the quality control I've witnessed. I used to work for a consulting firm, so I worked with a lot of manufacturing companies who said, hey, manufacturing companies said, we realize we need to implement our own quality control in-house because once a company experiences a bunch of things they put a bunch of money into this. I don't know what to use, brake pads. This company makes brake pads for the auto industry, right? And let's say they sell to all the auto industries, General Motors, Ford, whatever Chrysler's called now. I don't even know the name of Chrysler anymore. But let's say they're doing the brake pads. Once you've made 5,000 sets of brake pads and then had them declined and you had to take them back and fix them because the quality was so bad, That's the day you know as a supplier that you have to implement your own quality control in-house. That you never want that to happen again. And that's what then caused all the suppliers to start implementing quality control. Because once they saw an order get refused because of quality, they knew they never wanted that to happen again. So here's the deal. You ready? I'm a manufacturer now. I'm making a bunch of stuff. And as I'm making these brake pads or ball bearings or whatever it is I'm making it, every hour or every couple hours, I want the batch that just got made to be inspected. And this supplier says, I want that inspection to be done exactly how the big guys do the inspection who are buying my parts. Because they're gonna send someone over to do this inspection, and I'm not gonna be able to ship this unless I pass it. So I wanna do the inspection while I'm making them exactly the way they do it, so that I know for sure I'm gonna pass their inspection. So I never have to eat 10,000 brake pads again and have to redo them all, and the amount of money involved, there are thousands and thousands and thousands of dollars to fix an order that got refused because of the quality. So they implemented it. And this in-house is called, where am I here? During production, is called detection quality control, detection. The seller's doing it, and they're doing it during the production process. Sometimes it depends how important it is. Sometimes it's every 1,000 meg, sometimes it's every hour, sometimes, it all depends on how important it is, the process is, and how skinny the restraints are that you gotta be within, called the upper and lower control limits. All right, so now, you finish an order, and you've been keeping up with the quality, and you've been inspecting it, and you've been making sure the machines get adjusted if the quality starts to go off a little bit. And so you have an order ready to go called a batch. A batch is a full run, meaning there's a certain amount you had to make for that batch, and that batch is done now. This machine, matter of fact, is being retooled right now to make something else for another customer. This batch is done, brake pads are finished. You got a hold of General Motors, this is their order. Hey, we got this order ready, 10,000 brake pads, ready to go. We'll send our person right over. They send a male or female quality control specialist, comes over. Hey, you've seen this person so many times, you know them. They open up their laptop, they got their little machine, they hook the machine up to the laptop. They get it all started up. They start grabbing randomly choosing brake pads. Here's all the boxes, whatever process they're using, every brake pad has a chance to be chosen. They're grabbing some brake pads, and they're maybe grabbing, who knows, 10 of them, 20 of them, who knows how many, maybe 30, maybe because they're trying to form an inference, so that maybe they need at least 30, but they're grabbing brake pads. They have their little machine here. They take the brake pads, put them in the machine, it's doing its measurements, feeding it to the laptop. The program's all set up, boom. Another one, put it in, feed it in, boom. So let's say it was 10 of them. They did 10 of them, now they're clicking, they're done with those 10. It's calculating the average, whatever it is it's measuring. It could be the thickness of the brake pad, it could be the length of the brake pad. Whatever it is that's so important is being measured, there's the average. Now guess what happened? Those brake pads are set off to the side, we're doing it again. We're grabbing 10 more, 20 more, or whatever I said before, the same amount of them, putting them in the machine. Here we go, 1, 2, 3, all 10. Let's get an average there. And the person from General Motors who came to check this order before it gets shipped does this about 6 times, maybe 10. And that, every one of those little batches of 10 or 20 or however many that person was doing gets charted on a chart that looks like this. Looks like that. That's called a control chart. This control chart has a line in the middle. I'm colorblind, I don't know what color they are, I'm not even gonna try. Has a line in the middle, and that line in the middle is called the center line. That is where quality is perfect. Whatever the agreed upon measurement is right there at center line. And then you have an upper control limit, which looks kind of reddish or green up at the top. Red. The red line, this is definitely blue though, right?
Yeah.
Okay. The blue line is your lower control limit. So your lower control limit, upper control limit get calculated in advance. And those measurements that person did, those 6 or 7 batches of maybe 10 or 20 brake pads, the mean has to land for each one of those between the upper and lower control limit, or this order is refused. If just one of those fall outside that upper and lower control limit, this order is refused. My question for you is, look at this order. would you, if you were the quality control person, would you refuse this order based on the rules? Or would you tell this order to be shipped, and now you're gonna hand them what's called a PO, called a purchase order. PO's like money. Remember that. If you ever hear the phrase PO, purchase order, that's money. Once a company hands another company a PO, that's promising to pay. That's like cash. Here's your PO for $1 million for all those 10,000 brake pads or whatever it is. Here you go. They use that PO number as when they bill now and get paid. And as long as they've got a PO that's been signed, it's good as cash. They know they're gonna get their money. That now goes into their accounts receivable because they're getting their money eventually. It takes usually 30 days or 60 days depending on the situation. My question for you is, are you, as the inspector, are you gonna hand over the PO, or are you telling them you're not accepting this order?
You're not accepting the order.
You're not accepting it?
Yeah.
You're not accepting it either?
What's the rule?
The rule is that if each one of those brake pads, and we found the mean calculation of whatever it is we're measuring, and we put a dot on that control chart, and as long as if those dots fall within the upper and lower control limit, you have to accept the order.
So yeah.
And if it falls outside the upper and control limit, you are not accepting the order. They're going with not accepting the order because of which dot? The bottom right-hand one? Oh, you're leaving it up to her?
She was asking me.
I'm asking them
Oh, which dot?
I was gonna say the bottom right.
The
But
bottom right is almost out, but because it's still inside that blue line, you're accepting the order. You're gonna have to pay for it. All those dots stayed within those lines, but that's a great observation. In real life, I've looked at these. Let me show you how they really look in real life. Here's this, here's your center line right here. They usually go like this. And then, like this, like that. Not a straight line like that. And when I see a straight line like that in real life, that is saying possibly this machine's about to go out of whack and needs to be adjusted. Because they're usually all over the place. But here's the deal. The rule is that if you do all this inspection and the dots fall within the upper and lower control limit, you accept the order. Hand over the purchase order, you sign it, hand it to them, they now know they're gonna get paid. These 10,000 brake pads now can be shipped to General Motors, to the different manufacturing plants, and they're using them now in the manufacturing process. That's how it works.
Wait, can you explain that, please?
Explain what again?
That one.
This right here?
I'm not as scared.
See how the lines, see how the dots are in perfect order, almost forming a straight line? The batches you measure in real life almost never end up being a straight line. End up being a line that goes all over the place. The dots are all over because you're just randomly selecting brake pads. You know, if this one was happening during the manufacturing process, okay guys, it's been an hour, I'm gonna take 10 brake pads and measure them, I'm gonna take 10 more and measure them, maybe do it 2 or 3 times, and then put the dots there, and then I wait for a couple hours, I do it again, put 3 more dots. When it forms a straight line like that, heading down, that tells me something's happening to this machine. I wanna tell you the most common thing I've witnessed happening to machines that will cause it to go out of whack and not making a product exactly within specs. And that is what's called chance variation. Chance variation, random events that cause something that will make the quality of whatever's being made go out of whack. And in most cases, the companies that I was analyzing when I was working for this consulting firm, they would have a manufacturing machine, let's say in this corner of the warehouse. Let's say this is the warehouse. The offices are outside that door is offices, but this is the warehouse where everything's being made. A machine, a press machine, matter of fact, they're the worst. Boom, 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 stamping some piece of metal in this corner. Over here you have another machine that's going with constant vibration going on in that corner. And all of this is on a cement slab warehouse. That will cause vibrations, which will sometimes cause, especially in the old days. Today it's a little differently. They even have ways where they can correct themselves. But in the old days, that vibration and the banging would cause these machines to start going out of whack after enough time goes by. And you've got to constantly measure things. And when you see that starting to go, you get used to it. You realize the measurements are starting to go out of whack. You stop production, you readjust whatever needs to be readjusted on each of these machines to make sure they're back making things again exactly the way they should make them. That's how it works in manufacturing. In order to keep quality the way it should be, constant measuring of the things that are being made. The other thing that can happen to the machines are assignable variations, which would be like the correctable events. Hey, our supplier of raw material, this machine is stamping metal, but we got to get the raw metal from our supplier. If we got defective raw metal, that is something to be corrected. We don't use that metal anymore. We use a new batch that they're replacing because they said it's defective metal. That's called a assignable variation or a correctable event that takes place that causes quality problems. So those are all about what can cause quality problems in a manufacturing process. And those are the examples. Upper and lower control limit. You ready for these? That upper control limit, let me go back to this control chart. That upper control limit, when it comes to, we're measuring the mean. This isn't proportion. We're not talking about how many out of how many. This is measuring something. The brake pad thickness or the brake pad length or whatever it is that we're measuring has a mean. And the formula is you take the center line, whatever the expected measurement is, and you add 3 times the standard error of the mean, the standard deviation divided by the square root of the sample size. That in the parentheses is the standard error of the mean, the denominator from the homework 2 weeks ago, not the one you just handed in. That's proportion. The homework before that, the standard error of the mean, is what is on the right-hand side of this calculation in the parentheses. Standard deviation divided by the square root of the sample size. That gets multiplied by 3, so you're using 3 standard errors. And you're adding it and subtracting it from the center line. When you subtract it, that's that bottom blue line, which is called your lower control limit. When you add it, that's your top line, red line, and that's because that's called your upper control limit. Now, not every company uses 3 standard errors. Some companies say, look, this has to be, this ball bearing's got to be just this diameter. They may only use 2 standard errors or 1 standard error as an upper and lower control limit. But for this class and for our final exam, you can assume, and for your homework, that everything talked about upper control and lower control limits are 3 standard errors above and below the center line. Let me repeat that. For the final exam and for your homework, you can assume that even if you don't see that it says 3, you can assume we're talking about 3 standard errors above and below your center line. Everybody get it? For that upper and lower control limit. We're not going to stray from that for this class. In operations, you probably will though. You guys are just doing operations, just doing quality control right now, huh?
We have a final project where we have to interview a company.
Oh, really?
Yeah.
About quality control?
There's 4 components, and quality control is one of them.
Oh, nice. So my question for you is, can you manually calculate the upper and lower control limits as long as you know the sample size, the center line, or the expected, and the standard deviation? Those are the only 3 numbers you need. Can you plug them in there? Let's give an example. Here's my example. And I gotta go to, oh, I forgot to open it. Hang on, let me go here. It's from your textbook. It's on page 261 for your textbook. Here it is. Page 261. Okay, 261 for your textbook. This company produces 1-gallon jugs of milk, and they want to ensure the machine is operating properly. So every 2 hours, the company samples 25 jugs and calculates the following sample mean filling weight in ounces. Okay, what's the control? What's the center line? Excuse me, control line. What's the center line?
25.
How many? No, 3 is the number of standard errors you're gonna use to get the upper and lower control limit. What's the center line? What is it they're trying to make sure that's in every jug of this milk? Not 25, that's how many they're gonna use. That's the sample size.
Gallon?
How many? Not a gallon, but how many ounces? What's their goal? To have this, they wanna make sure this fills properly. It's 128. There it is.
That is a gallon.
I guess I didn't read that sentence. The firm that produces 1 gallon jugs of milk wants to ensure that the machine is operating properly. Every 2 hours, the company samples 25 jugs, calculates the following sample mean, filling weights in ounces. There we go. Assume that when the machine is operating properly, the mean will be 128 ounces. That's how many ounces in a gallon. So it's gonna, the goal is that we're gonna pick some at random and see if there's truly 128 ounces in them or not. And if this machine's not putting 128 ounces in, you know, our Walmart account is in jeopardy. Because people are complaining that when they get home, this thing looks like it's not filled up all the way. Or something like that's going on, possibly. Quality control is gonna check this. Now here's the weird part. Look at how many times we're doing this. First of all, is this inspection an acceptance or detection inspection? What was described in the story? A detection or acceptance inspection?
Hold on.
Detection.
The company, say it again.
Detection.
Because
They're just checking the weight.
Because it's happening during production. They're doing it every 2 hours as the milk's going into the jugs. That's why it's detection.
So it's
Detection is happening from the cellar during the manufacturing process.
So inspection will only be during the
The
buying process.
inspection's by the buyer after if all the milk jugs are completed. Hey, we've got 10,000 milk jugs here ready to ship. Then the acceptance inspection takes place by the buyer, who says, I'm not handing you this PO unless I know that those have 128 ounces in them. You know, we've been getting some complaints, these aren't being filled up all the way. So here's the deal. How many times does the inspector grab 25 jugs and inspect them and pours it? Now here's the deal. Opens up a laptop, takes this machine, plugs up the laptop, gets the software all set up. All these jugs have to have an even chance that just got made in the last, how many hours? 2 hours? Every 2 hours. So here's a whole bunch that just got made in 2 hours. Here's all the ones that were made in 2 hours are filled up. Randomly selecting 25, they all have to have a chance. Pouring it in, we're wasting 25 of them. Here we go, pouring it in the machine. Is this machine, is completely sanitized? Maybe we're pouring it right into another one though. I don't know if we're wasting it or not. But it's measuring exactly how much. There it is. How many times do you see up there that we did this process for this inspection?
6.
6 times. There it is. Are you ready? There's the numbers. Now hang in there with me. Are you ready? I want to review. What number would I put in this calculation for the center line?
128.
128. Plus 3 times. Now I didn't read this part of the story yet, but we know that the standard deviation is 2. 2 divided by, though, the square root of what? Uh-oh.
25.
The square root of what?
25.
Why 25?
Because that's a sample size.
As each sample size. I can't tell you how many people would think that you're going to divide by the square root of 6. Yes, we did it 6 times, but the sample size is how many were done each time. That's why it's 25. So it's the square root of 25, not 6. How many were in each time we did it?
Professor,
Go ahead.
where would the 6 play in this?
The 6 doesn't play. The 6 is how many times that we're told in training that we're gonna do this process to decide whether we're gonna keep, this machine needs adjusting or not. And that's my question for you is, we don't have the upper and lower control limit. You ready? We're gonna calculate it, and then I want you to look at this and tell me, does this machine need adjusting, or can we keep filling up jugs of milk? Go ahead.
Where'd you get the 6?
This, like I said, the person who's doing the inspection did it 6 times because they were trained to do it 6 times. How a lot of companies will decide how many times to do the inspection is how many times their customer will do the inspection based on accepting the order or not and handing over the PO. If they inspect it 6 times, then this company says, we want to do 6 of them then. But the 6 is not in the calculation at all. It just happens to be how many they want to do. Some companies find this so important they'll do it 10 times instead of 6 times. or 8 times or something. And sometimes we'll say, just do this 3 times or 4 times. You don't have to do it 6 times. So that, don't focus on that so much because that's not the calculation, but it's how many were used in each time it was done, which was 25, that's the sample size. So now, we go ahead and calculate that upper and lower control limit. Hang on, let me get the calculation here, we're gonna do it manually. So, 128 plus 3 times the square, standard deviation 2 over the square root of 25, order of operations, square root that 25, turn it into a 5. Divided into 2. 2 divided by 5 is 0.4, I think. 0.4 times 3 is 1.2, I believe. Add 1.2 to 128, you get 129.2. Subtract 1.2 to 128, you get 126.8. There's our upper and lower control limit. Look at our 6 tests. Look at the upper control limit. I haven't even made a control chart. Just look at the numbers. This is the question on the exam. Should this machine keep filling up jugs, or do we need to make an adjustment and stop that machine?
Make an adjustment.
Make an adjustment, make an adjustment. Christine?
We have to add and subtract?
Yeah, we gotta add.
Oh, so it's not either or, it's both?
No, you gotta do both. This is the upper and this is the lower.
Okay.
You gotta do both. Both add and subtract. So we got our upper and lower, 129.2, 126.8. They're saying this machine needs to stop and adjust it.
Why?
Why?
The numbers are off.
Because the numbers are off.
So is it supposed to be the same number?
What do you mean, same number? Like exactly the same number? No, what is the rule?
That's the
Do we need to see a control chart to know the rule? Adam, did you want to jump in on that one?
No.
Oh, okay, you can see you look like you wanted to. All right, so let's look, that's why we make control charts. Don't get me wrong, I'm a numbers person, so I can just look at those numbers and see if any of them are outside of them or not. But let's look at a control chart. There's the control chart. Are we telling them to stop this machine and restart it or not?
No.
No, because it's inside the 2 lines.
That's it. We're not starting the machine over. We are not stopping the refilling of this machine. Hi, Zink. How are you? Oh, I forgot the report answer. Okay, so because each dot is within the upper and lower control limit, we're not stopping this machine. Did you get that? We're not stopping it. Even though the numbers look like they're off, they're in between each of the upper and lower control limit.
So do we have to see the graph to be able to?
Some people need to see the graph. If you need to make a graph, go ahead.
Okay, how do
But without the graph, just look at the numbers. Look, hang on.
But
Whoop, there's the upper and lower control limit, hang on. 129.2, are any of these numbers above 129.2? No. 126.8, are any of these numbers below 126.8? No. That's how you do it without the graph. Since the answer is no,
It's below
none of those
or-
numbers are above or below it. They're inside, the machine keeps running.
that was my question.
Okay. Everybody get it? Can you answer this question on the exam? There will be a question on the exam, 99.9% sure. We're not having this lecture for nothing. You got it though?
What you want?
Can you make a
Speak up.
graph? Can you make, let's look at this control chart. Can you make this control chart? Again, I gotta,
I'm making it.
and the key is, you just draw 3 lines, make sure they're spaced evenly apart. The center line, you would put whatever the center line, whatever that number is right there. And then you're gonna be given 6 numbers maybe, 6 means from, we took 25 jugs, here's the 6 numbers. You put a line for the upper control limit, put a line for the lower control limit, and put your dots, just kind of guess where your dots would go. Yep.
Will you require us to do the graph?
Yes, maybe, you might have to make a control chart, yes, maybe. Not on the homework though. I think I already posted the homework, and there's nothing about a control chart there.
So we don't have to draw it, right?
Not on the homework. Not on the homework.
So we're,
Possibly on the final exam.
But it's better if we practice it at home.
You guys are making it sound like drawing a control chart would be hard.
It's easy.
Oh my gosh.
I can do that with my eyes closed.
It's so easy, I can't imagine putting it on there, except for all these questions are making me feel like I should. Well, huh?
No, I think you should.
I mean, you just draw 3 lines. Watch how long it takes me to make a control chart. There's my center.
Yeah, I agree with Alan.
There you go. All right, I'm done. That's that easy. Wow. I didn't, just maybe throw some numbers in, maybe.
It's so easy.
Throw some numbers in.
Do it in my sleep.
Yeah, same here. Okay. All right, so let's go. I want to review these definitions because here's your multiple choice questions. So I'm going back up to where are we here? Up, right here. Acceptance, sampling, used at the completion of a production process. This is done by the buyer. They then hand over a purchase order after they do the acceptance sampling. That's their part of the quality control. They're not taking the order until they do this inspection, right? So we got that definition. Detection sampling. Inspection occurs during the production process in order to detect a non-conformance to specifications, meaning we're making this as we're going. This is done by the seller. As the production process takes place, they're doing these inspections so that they can avoid the possibility of the buyer not accepting the manufactured batch that got done, right? All right, guys. Chance variation. You just gotta make sure you know the difference between chance variation and assignable variation. And the difference is chance variation caused by a number of randomly occurring events that are part of a production process. Let's see. Not controlled by any individual worker, it's just by a production process, blah, blah, blah. The most common, I wrote some common things I found under chance variation. Human misreading instruments, a vibration from one machine on the floor causing another machine to go out, things like that. Assignable variations caused by specific events or factors that can be easily identified and eliminated. The examples I have are defective material, just a mistake, a breakdown, maybe an accident took place, something that can be corrected and easily turned around. Control charts. You know what a control chart is? What are some of the parts of the control chart? It has a center line.
Upper control limit.
An upper control limit.
Lower control limit.
Lower control limit. Very good. Those are the main things you want to hear about on a control chart. It has some other things, the numbers, for example, but you know what they are. Upper control limit is taking the center line plus 3 times the standard error of the mean. Lower control limit is taking the center line minus 3 times the standard error of the mean. I think that's it. Oh, almost forgot.
My face?
This one.
My head.
Right here. You guys, when you're driving down the expressway, sometimes on the side of some buildings, a manufacturing building, let's say a supplier, they'll have like a poster or some kind of banner up that says ISO 9001 certified. You probably won't notice it unless you're looking. Well, this is a big deal. This is a big deal. This is a quality control certification, which means that that company is doing quality control inspections correctly. They're doing random selections correctly. They're doing everything right as far as quality control. Now, the reason this is important is because if you're at a company that is a supplier, a manufacturing company that supplies, let's say I keep using those brake pads or ball bearings, and you want to get a new customer. Hey, General Motors isn't ordering as many as they used to. Let's get a hold of Ford and see if they could use our brake pads. The number one question Ford's going to ask is, are you ISO 9001 certified? Meaning they only want to contract with suppliers that are doing proper quality control techniques. That's how important this certification is. This is just one of them. I can't remember, this is the most popular one that I'm familiar with. ISO 9001 certification. And you'll see it on the side of some buildings when you're driving down the highway because they want to announce. A small company who's trying to get customers want to announce, look, we're ISO certified. We do quality control here. You will get quality products if you buy from us. That's what they're trying to announce with this. That they've gone through the certification, that our employees have been trained. So that's an important thing you need to know. And, man, all right. Look at it. I'm down to, what says 1 hour? I'm down to 17%. I don't know why it says I still have an hour. That seems impossible. It went from 44% to 17% in the hour of our lecture. I do want to point out something that, here's the assignment, by the way. Oh my gosh, almost forgot. At the bottom of this week's instructions are some important dates. The last date to hand in old, late submissions or missing items is Tuesday, April 16th, a week from today. All right. After that, it's an additional 50% off, so the highest you could get to like a 20. Again, this is old stuff, not week 14's in-class assignment or week 13's homework that was due on Tuesday the 16th. That wouldn't be considered old, late assignment. But anything old. I looked, by the way, over the weekend. there is like at least a half a dozen zeros on assignments that maybe you guys aren't aware that you have a zero on because you just didn't look lately. Look and see if you got a zero on something and get that in, because you have only 1 week left now to get that in and get at least a 40 on it. Change a 0 to a 40. The other thing is last day for old assignments. What's this? Last day for participation credit of any kind will be Tuesday, the 23rd, 2 weeks from today, which is your last day here in this room at 9 o'clock for the second half of the final exam. All right, this week's assignment has 1, 2, 3, 4, 5, 6 parts to it. I think they're all calculating upper and lower control limit. On Thursday, we're gonna talk about how to do it using Excel. A couple of these you gotta do it using Excel. And we're also gonna talk about calculating the upper and lower control limits using proportion. Not just standard error of the mean, standard error of the proportion. So that's what's coming up on Thursday. So some of this homework you could literally do now. Some of it you're gonna have to wait till Thursday's lecture. Today's life lesson is called The 5 Keys to Career Happiness. Will this be on the final?
Maybe.
Thank you. I like that. I don't want to waste time. Oh, wait, we don't want this on the video. What am I saying? This is only for people who show up. Oh, sorry, I forgot. Let me get this off.